All right, here is part 2 of your review. And the best advice I can give you on these is don't try and make this too hard. And don't jump in and try and change a bazillion things at once. Think about what you're changing and why and how that might help you. So when we are proving the identities, we want to work with the side that looks more complicated. So I would say the left definitely looks more complicated. So this is my goal. So on the left here, I could make that secant squared into 1 over cosine squared, but I don't know if that would be that great. That looks like it's a Pythagorean type thing, so I can use one of my Pythagorean identities. I'm going to leave the numerator alone, so this is sine x over. So 1 minus secant squared, if you look on your chart, tangent squared plus 1 equals secant squared. So if I'm going to do 1 minus secant squared, I have to subtract tangent squared over, so that would be a negative tangent squared x equals, and then I have to rewrite the right-hand side. Okay. Also, don't let these dots confuse you. It just means multiplication. Like, I don't even write them. So then, as I look at this, I've got sine over tangent squared, and I know tangent sine over cosine, so I think here using my quotients will be good. So I'm going to get sine x over negative sine squared x over cosine x equals negative cotangent x cosine x. Then I've got, in the denominator I have a fraction, so I'm going to multiply by the reciprocal. I highly suggest you actually write that out because so many of you are saying you're doing that, but you're not really doing that. So when I take the reciprocal, this is still negative out front, and then it'll be cosine over sine squared x. So this sine cancels out with one of those, and that's equal to negative cotangent x cosine x. And then this gives me negative cosine over sine, which is, oh shoot, what did I do? I left off the squared here. Squared for cosine squared. Sorry, tangent squared becomes sine squared over cosine squared. Whew. All right, so I still cancel out one of those signs. So now I have cosine squared over sine, and it's still negative. Well, cosine over sine, so one of these cosines over sine gives me cotangent, and then I'm left with still a cosine in the numerator, and that's equal to negative cotangent x cosine x. And I'm done. All right, so number 28. I've got to figure out which side I want to work with. I think I want to work with the left-hand side. So I have 2 terms in the denominator. I don't like having 2 terms in the denominator, so I want to make it into 1 term, which means I need to use my quotients here. So cotangent is cosine over sine, plus tangent is sine over cosine. And that's equal to sine cosine. All right, so to get the common denominator in the denominator, that will be sine y cosine y. In the numerator, this is going to become cosine squared y plus sine squared y. That's equal to sine y cosine y. So this becomes 1. Then when I multiply by the reciprocal, 1 times this reciprocal is just sine y cosine y equals sine y cosine y. And I'm done. Check, check. Okay, number 29. I would say the left-hand side definitely looks more complicated, so I'm going to work with that and make that my goal. So got a couple options here. I think I'm going to go ahead and distribute in the numerator. So sine squared times sine squared is sine to the 4th alpha minus, and then sine and cosecant are reciprocals of each other, so when you multiply them together you get 1 over sine squared alpha plus 1. That's equal to negative cosine squared alpha. All right, so in the numerator over here, this is a difference of squares, so this can become sine squared alpha plus 1 times sine squared alpha minus 1. And then in the denominator, that is not a difference of squares, so this is just sine squared alpha plus 1. That's all equal to negative cosine squared alpha. So then I can reduce. These are being multiplied, so this cancels out with that. So I'm left with sine squared alpha minus 1 equals negative cosine squared alpha. And then sine squared plus cosine squared equals 1, so sine squared minus 1 is going to have to equal negative cosine squared. Alpha equals negative cosine squared alpha. And we're done. All right, so number 30. I would definitely say the right-hand side looks more complicated, so I want to make this my goal. So on the right-hand side, let's see, let me rewrite this. Cotangent theta plus 1 equals. So I'm going to leave this first fraction alone. 2 over 1 minus, 1 minus tangent theta times, okay, so then I have a cotangent of 2 theta. So I don't have a double angle for cotangent, but I do have one for tangent, so I can just use the reciprocal of that. And so the reciprocal would be 1 minus tangent squared theta over 2 tangent theta. Okay, so then rewrite my left-hand side. I can go ahead and cancel those 2's out. Then when I multiply the 2 together, my common denominator is 1, or my denominator rather, is 1 minus tangent theta times tangent theta. In the numerator, I have a difference of squares. So this is 1 plus tangent theta. Oh, sorry. I'm writing one thing and saying another. 1 plus tangent theta times 1 minus tangent theta. Okay, so then these 1 minus tangent thetas cancel out. So I get cotangent theta plus 1 equals 1 plus tangent theta over tangent theta. So now, if I split my fraction, I'll get 1 over tangent theta plus tangent theta over tangent theta. So cotangent theta plus 1 equals 1 over tangent theta is cotangent theta plus this is 1, and I'm done. Okay. All right, 31. So which side to work with? I think I want to work with the left-hand side. So that's my goal there. So over here I have 2 terms. This is 1 term and this is 1 term, and they have a common factor, so I'll factor out my GCF. Secant A times sine squared A plus 1 equals 2 secant A minus cosine A. All right, so factored out my GCF. I've got sine squared plus 1, which doesn't work for one of my Pythagorean identities, right? Because it would have to be sine squared minus 1 or 1 minus sine squared, so that's actually not getting me anywhere, okay? And this is going to happen to you. That's why I started this one this way, because that looked good, factored it out. We factored out a lot of stuff where it worked out beautifully. This isn't really helping me. I could start to substitute some stuff, and I'm not saying that I couldn't get there eventually, because I could substitute a 1 minus cosine squared in here, and then I could do some stuff. But instead, I think I'll just back up a step. Okay, so I can leave my right-hand side there. But I think over here, since that factoring didn't seem to do what I thought it might, or it didn't seem to help right off the bat, I think maybe I'll use my reciprocals here. So I'm going to make this sine squared A over cosine A plus 1 over cosine A. So now I'm thinking, all right, well, I guess I'm kind of at the same spot I was before, right? Because I still have that sine squared A plus 1, right? So if you feel like you're going in circles, sometimes maybe you are. But at the same time, maybe we just need to go with it, right? Just where, like, if I had kept going with the first one. So it still doesn't really change kind of what I had. I still have this, and technically I could still factor out that secant. But instead, I know what I can do. I've got a common denominator, so that's good. And sine squared is 1 minus cosine squared. So I'll go ahead and substitute that. So 1 minus cosine squared A plus 1 all over cosine A. And having two terms is not really bad in the numerator because I have to have two terms over here anyway when I'm done. So 2 secant A minus cosine A. Right. So now if I clean this up, I'm going to get 2 minus cosine squared A over cosine A equals 2 secant A minus cosine A. So I have two terms. I'm going to split them. I'm going to get 2 over cosine A minus cosine squared A over cosine A. So I had two fractions, I put them together, and then I split them back, but that allowed me to take care of some stuff in there. So this I can rewrite as 2 secant A minus, and then when I cancel out one of those cosines, that's cosine A, and I'm done. And remember, on any of these that I'm doing, I'm not saying it's the only way, not even saying it's necessarily the best way. So there could possibly be different legal ways. There also could be possible ways you're doing it illegally and getting lucky. So just keep that in mind. All right, on 32, I definitely need to work with the right-hand side, right? So this is my goal. So negative cosine 2x equals. All right, so the first thing I want to do is take care of this right here. So I'm just going to rewrite this. 2 sine x times, and then this is my sine of a minus b. So when I do that, this is going to be sine pi times cosine x minus cosine pi sine x minus 1/2 cosecant x. Okay, I need to close this, and I should have, well, I put in these two terms. I don't really need parentheses around them in there because I'm just subtracting one term after that. Okay, so now I need to clean that up. So negative cosine 2x equals, so this is going to be 2 sine x times, so this is sine of pi. Sine of pi is 0, so 0 times cosine x is 0. And then cosine of pi is negative 1, so negative 1 is a positive sine x minus 1/2 cosecant x. Okay, so I've cleaned up those. Rewrite this. Negative cosine of 2x equals, so then I'm going to distribute 2 times sine x times sine x is 2 sine squared x. 2 times a negative 1/2 is negative 1, and then sine times cosecant is 1. And so 2 sine squared x minus 1, if you look on your cosine of 2x options, that's not exactly what it looks like, but if I want to flip them around, all I have to do is factor out a negative 1, so this becomes 1 minus 2 sine squared x. This does equal cosine 2x, so that's why we get negative cosine 2x equals negative cosine 2x. And we're done. All right, last page. Now we're going to solve the equation for the solutions in the given interval. So I need to solve for theta here. So I'm going to start by dividing by negative 8. So cosine theta equals negative square root of 3 over 2. So that means that theta equals, so cosine is negative in quadrants 2 and 3. So in quadrant 2, to get negative square root of 3 over 2, that would be a pi 6th angle. That means this is 5 pi 6ths. But I'm going from negative infinity to infinity, so it should be plus or minus 2 pi n. And then quadrant 3 would give me 7 pi 6ths, oops, plus or minus 2 pi n. Okay, so then 34. Got cosecant squared beta equals 2 cotangent beta. So remember, I either want them to be the same trig function or I need to be able to factor them away from each other. And I know that cosecant and cotangent are related in the Pythagorean identities. Cosecant squared can be changed to cotangent squared beta plus 1. That'll equal 2 cotangent beta. So then I set it equal to 0, and cotangent squared beta minus 2 cotangent beta plus 1 equals 0. Then I need to factor. So this will give me cotangent beta, cotangent beta. This is positive, so these have to be the same. So minus and minus happens to be minus 1 and minus 1, because you could have just factored it straight into cotangent beta minus 1 squared. Either way, I'm only going to have one answer in the end. So cotangent beta equals 1, which means tangent beta equals 1. So beta, we're going from pi to 2 pi. It's here. The only time tangent is positive down here is in the third quadrant. So this would be 5 pi fourths. Alrighty, so let's look at number 35. We've got sine squared a, and then I have a cosine of 2a and a sine of a. So the only thing I know I have to change is this one right here. And the nice thing about that, I mean, it's good and bad. It depends on how you want to look at it. I've got options. So I don't want to just willy-nilly pick something. I want to pick something that would be the most helpful. And since these other two functions here are both sine, I want to use the one that only has sine in it. So this is going to be 4 sine squared a equals negative. And then I substitute in cosine 2a will be parentheses 1 minus 2 sine squared a plus 3 sine a. Okay, so I get 4 sine squared a equals negative 1 plus 2 sine squared a plus 3 sine a. Sine a. So it's quadratic. I want to set it equal to 0. So move everything over to the left. So 4 sine squared, oh, not 4 anymore. I guess I should pay attention to what I'm moving. I've got 4 sine squared on the left and 2 over here. So when I subtract it out, I'm going to get 2 sine squared a minus 3 sine a plus 1 equals 0. Okay, so then I have to factor. So I'm going to get 2 sine a and sine a. Again, these are both, this is positive, so these both have to be the same. And since this is negative, they're both negative. The only two numbers that multiply to give me 1 are 1 and 1. So then that tells me that sine a is 1/2 and sine a equals 1. So I'm going from pi halves to 3 pi halves. Sine is 1/2 at 5 pi 6, and sine is 1 at pi halves. So overall, I get pi halves and 5 pi 6. Okay. So here I've got a sine squared, a cosine, and a cosine squared. So overall, I think the cosines are what I'm going to have to keep because I can change this into something cosine-y. So I get negative 2 plus sine squared would be 1 minus cosine squared y equals 3 cosine y plus cosine squared y. So I will move everything over to one side. It doesn't always have to be the left because if I move this to the left, my squareds are negative. I don't want that to happen. So I'm going to move everything to the right. So this will give me 2 cosine squared y plus 3 cosine y plus 2. No, plus 1. Wait a minute. Plus 1. Shoot. Sorry. I've got this negative 2 and this positive 1, so it gives me a negative 1 over here, so I end up with a plus 1 there. Okay, so then I have to factor. Get 2 cosine y and cosine y. This is positive. These have to be the same. This is positive, so they're both positive. This is a 1, so this has to be 1 and 1. This becomes cosine y equals negative 1/2, and cosine y equals negative 1. All right. So I'm going from 0 to pi right here. So this gives me y equals 2 pi thirds, and this gives me y equals pi. So overall, y equals 2 pi thirds and pi. All right, 37. I've got a half angle here, and for my half angles for cosine, I don't have a choice. There's not options. There's only one thing I can substitute in. So this gives me 1 plus cosine beta equals square root of 3 times plus or minus the square root of 1 plus cosine beta over 2. All right, so that I substituted in the half angle. Now I need to get rid of that square root, which means I'm going to have to square both sides of this. So this whole side has to get squared, and this whole side has to get squared, which means I'm going to put a little star up here because I have to check my answers at the end. So on the left-hand side, I'm going to get 1 plus 2 cosine beta plus cosine squared beta equals, when I square this side, this will give me 3 times 1 plus cosine beta over 2. All right, so the first thing I would like to do is to get rid of that 2. So I'll multiply both sides by 2. This will give me 2 plus 4 cosine beta plus 2 cosine squared beta equals, now this 2 cancels out here, and I'm going to go ahead and distribute that in there. I get 3 plus 3 cosine beta. So I have a quadratic. I'm going to move everything over to the left. So I get 2 cosine squared beta. I subtract the 3, so then I get plus cosine beta minus 1 equals 0. So then I need to factor. This will be 2 cosine beta and cosine beta. This is negative, which means my signs are opposite. I know the numbers have to be 1 and 1, but I got to figure out what the signs need to be inside of here. So if I want this to be positive, I need my 2 when I multiply to be positive and this 1 to be negative. So that's what I get. Then I get that cosine beta equals 1/2 and cosine beta equals negative 1. I am going from 0 to 2 pi, that's the whole circle. So I get here that beta could be pi thirds or 5 pi thirds. And here beta would be pi. So overall, beta is pi thirds, pi, and 5 pi thirds. But I have to check my answers because I squared both sides. So when I do that, I take each one of these and substitute it back into the original one. So I can do 1 plus cosine of pi thirds equals the square root of 3 times the cosine of pi thirds over 2, which would be pi sixths. So this gives me 1 plus 1/2 equals the square root of 3 times the square root of 3 over 2. So this gives me 3/2 equals 3/2. So this one works. So this one's good. Then I'm going to do 1 plus, I'm going to use pi, cosine pi equals the square root of 3 times cosine of pi halves. So this is 1 plus a negative 1 equals the square root of 3 times 0. So that gives me 0 equals 0, and that one works. Then I do 1 plus cosine of 5 pi thirds equals the square root of 3 times cosine of 5 pi sixths. So this gives me 1 plus 1/2 equals the square root of 3 times a negative square root of 3 over 2. So this gives me 3/2 equals a negative 3/2, and that is not true, so that is actually not one of my answers. Okay. All right, last one. So I have the sum and difference of angles going on here, so I'm going to substitute in here the sine of a plus b and the cosine of a minus b. So when I substitute that from my reference chart, I get 2 times sine x cosine of 5π6 plus cosine x sine of 5π6, close my parentheses, plus 2 times parentheses cosine x cosine of π3 plus sine x sine of π3. All that's equal to the square root of 2. Okay, so then I go in there and I evaluate what I can. This is 2 times. All right, the cosine of 5π6 is negative square root of 3 over 2 times sine x plus 1/2. Sine of 5π6 is 1/2, so I get 1/2 cosine x. Close my parentheses. Plus 2, open parentheses. Cosine of π3 is 1/2, so I get 1/2 cosine x plus, then sine of π3 is square root of 3 over 2 times the sine of x. All that equals the square root of 2. So now I'm going to distribute my 2's. This gives me negative square root of 3 sine x plus cosine x plus cosine x plus square root of 3 sine x equals square root of 2. So negative square root of 3 sine x and square root of 3 sine x zero out. This gives me 2 cosine x equals the square root of 2. So cosine x equals square root of 2 over 2. I'm going from pi to 2 pi. So cosine is square root of 2 over 2 at 7 pi fourths. And there you have it.